Okay friends, now let us discuss question number 3 and 4 from code 9 of JEE Advanced 2015 paper 1. In this question we are given with a setup of a mirror and a lens, and we have to compare the magnification in two cases. In first case, the complete setup has been placed in the refractive index of air, and in second case we have actually changed the medium in which this complete setup has been placed. Okay, so to solve this question, what we have to do, first we have to find the image which will be formed by the mirror. Then that image formed by the mirror will work as the object for the lens, and then we will find the image formed by the lens, and then we have to compare the magnification. As we know that the resultant magnification will be the magnification due to mirror multiplied by magnification due to lens. Okay, so now let's start solving the problem. And this we are given that focal length of the lens is actually 10 centimeter, and the object has been placed at a distance of 15 centimeter. Okay, so as we know that our mirror formula is 1 by f is equal to 1 by v plus 1 by u, and rearranging this formula I can say that v is equal to f u divided by u minus f. Now putting the values, what we will get as v will be, let's say our f is minus 10, our u is minus 15, and this is minus 15 plus 10, and what we will have minus 30 centimeter. Minus 30 centimeter means the image which will be created will be in front of the mirror, and it will be at a distance of 30. As the total distance given to us is 15, we can say that the image will be formed at 20 centimeter from the lens. Now the focal length which has been given to us for the lens is also same, which is 10. So as we can see that our object, which is actually the image formed by the mirror, is placed at 2f. So its image will also be formed at 2f, and the magnification will be actually 1 due to the lens because it has been placed on 2f. Okay. So our magnification for first setup will be actually the magnification due to mirror multiplied by magnification due to lens. Okay, so now let's take our second case. In the second case, when we will keep the whole setup into a different medium, nothing will change for the mirror, but definitely the focal length for the lens will change. As we know that the focal length for a lens can be is given as mu2 divided by mu1 minus 1 into 1 by r1 minus 1 by r2. In first case, the focal length which is given to us is 10. So we can say 1 by 10 is equal to 3 by 2 minus 1 into 1 by r1 minus 1 by r2. And from this we can say that this is equal to actually 1 by 2 into 1 by r1 minus 1 by r2, and from here we will get the value of 1 by r1 minus 1 by r2, which is actually 1 by 5. Okay, so now in the second case the focal length will change when we will submerge the whole thing into the refractive index of 7 by 6. In this case it will be equal to 3 by 2 divided by 7 divided by 6 minus 1 into 1 by r1 minus 1 by r2, which we have just calculated as 1 by 5. So this will be equal to basically 18 by 14, and 18 by 14 we can say 9 by 7. So 9 by 7 minus 1 into 1 by 5, and this will be equal to 2 divided by 35. Okay, and from this we can say that the new focal length of the lens will be equal to 35 divided by 2 centimeter. As we are taking all the measurements in centimeter, that's why our focal length will also be in the centimeter. Okay, so now in this case also the image that will be formed by the mirror will be at the same position, which is actually 20 centimeter away from the lens. So using the formula, what we can say that using the lens formula, we will have V is equal to F U divided by U plus F, and our F which is given to us is 35 divided by 35 divided by 2 multiplied by the U which is minus 20 divided by 35 divided by 2 minus 20, and if we will solve it, okay, so let's solve it, and let's say we multiply both sides by 20, so we will have 35 multiplied by minus 20 divided by 35 minus 40, which is actually equal to 5, and we can cut this 5 from here, and we will have this 7, and actually it was minus 5, so this minus sign will also get cancelled. So we will have our V as 140 centimeter. Okay, so our the magnification in second case M2 will be equal to the magnification due to mirror multiplied by magnification due to lens. Okay, so in this case the in first case the magnification due to lens was actually 1, because the distance of the image and distance of the object both were same, and magnification due to mirror will remain same in both cases. In second case we can see that magnification due to lens is equal to 140 divided by minus 20, which will be actually equal to minus 7. Okay, so what we will have M2 divided by M1, and if we take the magnitude of this will be equal to mm into ml in case 1 divided by mm in case 2, actually mm into ml in case 1. So mm in both sides it will cancel, and it will be 7 divided by 1. So the 7 will be our answer to the problem. Okay, so now moving to the next question, what we are given that we have this infinite length straight wire which is carrying the charge at a charge density of lambda, and then we have this small area in xy plane, and we have to find the flux passing through this area due to this infinite long wire. In this case, as we can see that the distance of the wire from this area is not constant, we have to integrate to find the solution of this problem. Let us say we take a elemental area which is at a distance of r from our central position, and let's say its width is dr. Okay, so now the area of the small area due to this elemental strip will be equal to dr is the width and l is the length, so the area will be equal to l dr. Okay, and the electric field due to this wire at this point, as you can see that this distance, let's take this distance as h, and let's say that it is at height of d from the origin. So this h we can calculate using Pythagoras theorem easily. Okay, so this wire is at a distance of h from this elemental area, So we can say that electric field due to the wire will be equal to lambda divided by 2 epsilon naught into H. Okay. And now as you can see that area vector is in the downward direction and the electric field is in this direction. So they are making an angle theta with each other. So to find the dot product, we will need the value of cos theta, and we can calculate the cos theta from this small triangle, and the cos theta will be equal to, the value of cos theta will be equal to base, which is actually d, divided by our hypotenuse, which is h. Okay. So now this small flux d phi is equal to E vector dot dA vector, and which is actually E dA cos theta. And we can integrate it within the limits to find what will be the value of total flux. So our total flux will be equal to, if we integrate this small area within the limits, and our variable is actually dr, and the value of r is changing from minus a by 2 to plus a by 2. From here at this point we have minus a by 2, and here we have plus a by 2. So it is minus a by 2 to a by 2. And now the putting value of E, dA and cos theta, we will have lambda divided by 2 pi epsilon naught h multiplied by L dr multiplied by d divided by h. Okay. Now taking the constants out, lambda is constant, okay, our d is constant, L is constant, and now in the denominator we have 2 pi epsilon naught as constant. Okay. And we will have minus a by 2 divided by a by 2, and inside we will have dr divided by 1. We have 1h here, 1h here, so it is h square, and using Pythagoras we can say that h square is equal to r square plus d square. Now we know that this integration is direct formula we have, and this is the integration of 1 by d tan inverse r divided by d. Okay. So we will get pi d L divided by 2 pi epsilon naught. Okay. And then the integration of this will be equal to 1 by d tan inverse of r divided by d, and the value of r will vary from minus a by 2 to a by 2. Okay. And this d gets cancelled out from here, so we will have pi L divided by 2 pi epsilon naught. Okay. And then we have tan inverse. Now putting the value of d, which is given to us as root 3 by 2a, we will have 2r divided by root 3a, and the value is from minus a by 2 to a by 2. Okay. So this we will have lambda L divided by 2 pi epsilon naught. Now putting the values, we will have tan inverse 1 by root 3 minus tan inverse of minus 1 by root 3. Okay. And if we will get the value of tan inverse 1 by root 3, which is equal to, this will be equal to pi by 6, and we will have this minus pi by 6. So this total term will come as pi by 3. Okay. So it is lambda L divided by 2 pi epsilon naught into pi by 3. From here this pi get cancelled out, and we get lambda L divided by 6 epsilon naught, and comparing this equation with the value which has been given to us in the problem, we can say that the value of n will be equal to 6, which will be our answer to the problem.